So let's take a look at rational exponents. So we know that square roots undo powers of 2. And so when we have square root 9 equals 3, we can say that the opposites, 3 squared equals 9, or in other words, the square root of 3 squared equals 3. So the square root and square undo each other. We know that the cubes undo powers of 3. We know that, so 2 cubed equals 8. If we undo the cube root with a cube, okay, we end up back with our 2. So in general, we can say that a fourth root undo powers of 4. Okay, so we have, for example, we can have the fourth root of 16. That's going to be equal to 2. And we can show that 2 to the power 4 equals 16. And we know that that power 4 can be undone by a 2. Undone by a fourth root. And in general, an nth root undo powers, sixth root undo powers of 6. Okay, so if we have 2 to the power 6, that's equal to 64. I'll write it this way. So we know that the sixth root of 64 is equal to 2. Okay, you can check that on a calculator if you want. And then we can undo this power of 6. 2 to the power 6 equals 64. We know that the sixth root of a sixth power will undo each other. So essentially, if roots and powers undo each other, roots must be a type of power. Okay, in fact, they are. But what power do we use to show a root? So if I have the square root of 5, it can be expressed as some power. And what is that power? So let's take a look at what that power might be. So this is an argument we're going to make. We can say that square root in red here is undone by that square in green. So we can rewrite that square root as a power a. Okay? So these must undo each other. And we can then say that, well, if they undo each other, we can rewrite this as, well, square root 5 to the power 2 is going to give us the power of 1. They're just going to undo each other. And that's going to be equivalent to, well, we know the power to power rule here. So we have 5 to the power a to the power 2 represents a power of 2a. And since these are equivalent expressions, we must be able to say that this power of 1 must be equal to 2 times the power that represents the square root, which is a. Okay, remember that a up here must be the same as that square root. So what is on that power? What power is the square root? Well, if I solve for this, I can see that algebraically, if these are equivalent, I can solve it. And I can say that a must be power 1/2. So power 1/2 is the same as square root. Okay? And in fact, we can make the similar arguments for any other root. And we can generalize that an nth root is just going to be a power 1 over n. Okay, just like the square root here becomes a power 1 over 2, an nth root becomes 1 over n. And so if we can express this as a power, we can just apply any other power rule to it, just like we did with powers. And this is going to be very useful to us.